So let's try this declaration of an array of 10 integers in our code. I'll add to our data segment this new portion. We can say my array, and I like to place these labels on a separate line, split them like this. And so here it deserves a comment that we are actually allocating space for 10 integers. You can always press Ctrl S to save your code. And let's see how we can load an element from this array into one of the registers. So before we even begin to read any data from memory, what we need to do is to load the address. Alright, so something like this. We take the name of our label and use it to load register T2, and the command mnemonic that we use is load address LA. Okay, so let's align our comments. So the basic instruction to read integer from memory is called load word, LW, and so that's the format. So here, if we add this line, load word, and I guess we can add a comment that the result of this operation is T1 gets loaded with the value of the first element of our array. And we say that in this syntax, $T2 is the base address referring to our data segment, and 4 is a 4-byte offset from this base address into that memory. And it doesn't feel right because this is uninitialized space, we don't know what's there, but because this is a global data segment, the entire memory should be initialized to 0. So I'm expecting that we'll be loading a 0 in this register T1 by using this load word command. Remember that word in MIPS specification is a 32-bit integer. So we can now build this program by using this shortcut on the toolbar. Okay, so our messages indicating that the assembly completed successfully. And this is the compiled version of the program with the RISC instructions like this. So these are the opcodes that include all of the information that we provided. And this is the source with numbers referring back to the original source code. So once the program is built successfully in the simulator, we're ready to start running it. So we can now try to step one instruction at a time using the shortcut. Alright, so execution begins. And as the values of our registers change, they get highlighted here in the register display panel. Also, I would like to clear our messages so that we have a clear view of what we're going to print or see in this output. And I'm just going to continue stepping one line at a time. Alright, so we step, making the syscall, which prints hello world. And now comes our next fragment, which is basically loading the address of our array into register T2, which is right here. So we'll make it another step, and here it gets new value, which is hexadecimal 1001000E. And we're now ready to execute our next command, which is reading this integer from memory. So let's do the next step. And suddenly we get this error message. So we actually switch from the input-output panel to the messages in this environment, and you can see that it tells us that the fetch address, basically the address that we loaded into our register right here, has to be aligned on the word boundary. And in our case, if you look at our program, we arbitrarily provided some characters and reserve space for this message. Then we decided to allocate space for some integers, an array of integers. And the rule goes that each integer has to be, according to its size, the word size, has to be aligned on the word boundary. Okay, and apparently if you look at this value right at the end of our address that we obtain here in register T2 after loading the address of this label, my array, which is really an odd number, which tells me that it is no way aligned on the word boundary, which has to be always even because it's like a 4-byte increment of every next address. So what's the solution to this? So we can take a look at this help and directives, and the first one here is that there is an align directive that helps assembly to align next data item, which in our case, after ASCII 0 space directive, should be aligned on a specific byte boundary. 0 for bytes, 1 for half bytes, 2 for words, and so forth. So let's do this. I suppose that if we insert this directive saying align, and for the word we're going to choose 2, right? So we can now save this. I press Ctrl S to save my code. Just be very careful that this directive has to appear before our label so that we stay clean with our address of the word boundary. And let's try this again, build. And then, so it says that the operation completed successfully. Apparently the syntax of our align looks good. So now switch back to execute. I typically prefer to clear these outputs and messages and outputs, all of them, before I start new attempt to run my code. And let's try our steps again. Step, step, step. syscall. First we print hello world, and then we step more and load address. And so this time the address is actually an even number, which tells me that this is something that aligned on the word boundary better than we had last time. So we step more, and this time we load it into T1, this value, which is 0, which is expected, since all uninitialized memory should be initialized to 0 by the linker. All right. And one more note on the actual address of our array. So you see that we've been able to load the address of the beginning of our array into register T2, which is this value, which is like 10010010. And so the base address shown here in this data segment view starts with all zeros. So then it shows that this is offset 0, offset 4, 8, then 12, and this is plus 10. So this memory location right here, which is showing us our integers, 32-bit size values. So this is the first element of our array, and this is the next one. So base address of the array plus 4 is this value right here. So I'm assuming that the address here is pointing to this place. So it's just important to be able to identify your addresses with the data segment view that this environment showing us right here. It's important for debugging and verifying everything that's going on at runtime. If you want to reset your program back, you can just click this toolbar button and you can run it again. So if you don't want to step through, then you can just press the green button and it'll run again.